The WOW signal. Back in 1977, an astronomer named Jerry Amon was scanning the skies with a giant radio telescope in Ohio. Suddenly, his data showed something strange, an extremely powerful radio signal blasting in from deep space. It lasted for just 72 seconds, nothing before it, nothing after it. Amon circled it on the computer printout and scribbled one word next to it. Wow. That's why we call it the WOW signal. Now here's the thing. Space is full of noise. We get radio signals bouncing around from Earth, satellites, cosmic rays, you name it. But this was different. The WOW signal was at a very specific frequency, 1420 megahertz, which is tied to hydrogen, the most common element in the universe. Scientists have long believed that if aliens ever tried to contact us, they might use that exact frequency, because it's like a universal channel. The strangest part? We've never heard it again. For almost 50 years, astronomers have pointed telescopes back at the same spot, waiting for a repeat. Nothing. It's like someone picked up a phone, said one word, and hung up forever. So what was it? The theories are all over the place. Some say it was a passing comet reflecting radio waves, but that explanation doesn't fully add up. Others argue it might have been a secret military transmission we weren't supposed to hear. And of course, the wildest theory, the one fans of sci-fi love, is that it was a deliberate message from an extraterrestrial civilization. The WOW signal is maddening because it's a mystery with no follow-up. One single blip that could mean nothing, or it could mean everything. In the vast silence of the cosmos, it remains the closest thing we've ever had to a missed call from aliens. Fast radio bursts. If the WOW signal was a one-time missed call, then fast radio bursts, FRBs, are like the universe butt dialing us over and over again. First discovered in 2007, these are insanely powerful blasts of radio waves that come from billions of light years away. We're talking about as much energy in a few milliseconds as the sun produces in an entire year. And then, poof, they're gone. At first, scientists thought they were glitches. Maybe the telescope equipment was acting up. But then more kept showing up, from different parts of the sky, detected by different telescopes. So no, it wasn't a glitch. Something out there is screaming across the cosmos, and we have no clue why. The weird part? Some FRBs are one and done, like cosmic fireworks that never repeat, but others actually keep coming from the same spot in the universe, repeating on strange rhythms. One even had a 16-day cycle, blasting every couple of weeks like clockwork. That's not random, that's a pattern. And patterns always raise eyebrows. So what's causing them? The safe guess is exotic stars, like magnetars, neutron stars, with insanely strong magnetic fields. These could be cracking, collapsing, or colliding, and each event sends out a blast of energy. But other theories are wilder. Could it be alien technology? Imagine a super advanced civilization using giant radio transmitters, either to power spacecraft with beams of energy, or maybe to communicate across galaxies. Right now, we've cataloged hundreds of FRBs, but we're still just scratching the surface. They're scattered all across the universe, with no clear origin story. And the kicker? We're detecting more all the time. FRBs are the kind of mystery that makes scientists excited and nervous at the same time. They prove the universe is still filled with surprises, signals that last a blink of an eye but carry enough energy to power a planet. If the WOW signal was a whisper, FRBs are thunderclaps, and we still don't know who or what is making the noise. Oumuamua. In October 2017, astronomers in Hawaii picked up something bizarre moving through our solar system. It wasn't a comet. It wasn't an asteroid. It was something completely different. They named it Oumuamua, a Hawaiian word meaning scout or messenger. Fitting, because this thing looked like it came from somewhere far beyond our neighborhood. At first, scientists thought, okay, just another space rock passing by. But then the weirdness started piling up. Unlike comets, Oumuamua had no visible tail of gas or dust. Unlike asteroids, it didn't reflect light in the usual way. To make things even stranger, it sped up slightly as it moved away from the sun, like something was pushing it. But there was no outgassing, no jets of gas to explain the acceleration. and then came the shape. Based on how it reflected sunlight, scientists thought it could be cigar-shaped, maybe 10 times longer than it was wide. Others argued it might be flat, like a pancake. Either way, it looked nothing like any natural object we'd ever seen in our solar system. This is where the theories went wild. Some said it might be a shard from a shattered planet, flung across the galaxy. Others proposed it was made of exotic ice, like solid hydrogen, which could evaporate invisibly and explain the acceleration. But the most controversial theory came from Harvard's Avi Loeb. Maybe Oumuamua wasn't natural at all. Maybe it was an artificial object, a piece of alien technology, like a probe, or even a discarded solar sail drifting through interstellar space. Of course, the scientific community wasn't thrilled with the alien idea. Most say it was likely a natural object behaving in a way we don't yet understand. But here's the frustrating part. We'll probably never know. Oumuamua zipped past Earth, moved out of telescope range, and disappeared into the blackness of space. What was it? A cosmic rock with strange physics, or the first interstellar visitor we've ever detected? All we know is that for a few weeks in 2017, the universe gave us a mystery, and then it left without answers. Tabby's star. In 2015, astronomers noticed something really odd about a star 1,500 light-years away in the constellation Cygnus. Its official name is KIC 846-2852, but everyone knows it as Tabby's star, after the scientist who studied it, Tabitha Boyajian. Now, stars usually flicker in predictable ways. If a planet passes in front, the light dips slightly, and then comes back. That's how we find exoplanets. But Tabby's star wasn't playing by the rules. Its brightness wasn't dipping a little. It was dropping by as much as 20%, and it wasn't on a clean schedule either. Sometimes it dimmed for days, sometimes for months, sometimes for years. No other star we'd seen behaved like this. Naturally, the internet went wild. The strangest idea was the most exciting. What if it was an alien megastructure? Imagine a massive swarm of satellites, or a Dyson sphere, partially blocking the star's light as an advanced civilization harvested its energy. Suddenly, Tabby's star became the hottest mystery in astronomy. But scientists had to be more cautious. Other theories started rolling in. Could it be a massive cloud of dust orbiting the star, scattering the light? Maybe the star had swallowed a planet, leaving behind debris that blocked its glow. Some even suggested giant comets breaking apart one after another. The problem is, none of these explanations fully fit the data. Follow-up observations showed that the dimming was stronger at blue wavelengths than red, which hints that dust is probably involved. But the pattern is still strange, and no single theory explains everything we've seen. For years, Tabby's star was the ultimate what-if mystery. Today, the alien megastructure idea has mostly been put to rest, but the truth is, we still don't have a definitive answer. Tabby's star reminds us of one thing. When the universe does something we don't understand, our first instinct is to imagine aliens. And maybe that's not such a crazy instinct, because if a star really did dim because of alien technology, it would look a lot like this. Dark matter. Look out into the night sky and you'll see billions of stars, galaxies, and glowing clouds of gas. But here's the twist. All of that, the stuff we can actually see, makes up less than 5% of the universe. The rest, it's invisible, and most of it is something we call dark matter. Astronomers first realized something strange was going on back in the 1930s. Galaxies were spinning way too fast. If you only counted the stars, the galaxies should have flown apart, but some invisible glue, was holding them together. That something had to have mass, but it wasn't giving off any light. Hence, dark matter. Since then, we've found even more evidence. When we look at how galaxies bend light, what's called gravitational lensing, we see way more gravity than the visible matter accounts for. It's like there's a hidden skeleton of mass shaping the universe, but we can't see it directly. So what is dark matter? That's the unsolved part. It could be some kind of exotic particle we haven't discovered yet, like WIMPs, weakly interacting massive particles, or axions. It could be primordial black holes, tiny ones left over from the Big Bang. Or maybe our understanding of gravity itself needs to change. The frustrating part is, Despite decades of experiments, we've never actually detected dark matter particles. We build massive detectors in underground labs. We send satellites to scan the skies. And still, nothing. Every time we think we're close, the results slip away. And yet, we know it has to be there. Without dark matter, galaxies wouldn't exist, stars wouldn't form, and the universe would look completely different. It's the invisible scaffolding holding everything together. Dark matter is like the universe's biggest inside joke. Everything depends on it, and yet we can't see it, touch it, or prove exactly what it is. Until we figure it out, more than a quarter of the cosmos remains a ghost story. Dark energy. If dark matter is the glue that holds the universe together, then dark energy is the mysterious hand that's ripping it apart. In the late 1990s, astronomers were studying distant supernovae to measure how fast the universe was expanding. They expected the expansion to be slowing down over time. After all, gravity should be pulling everything back together. But what they found shocked everyone. The universe isn't slowing down, it's speeding up. Galaxies are flying away from each other faster and faster, as if some hidden force is pushing them apart. That unknown force is what we call dark energy. And here's the mind-bending part. Dark energy makes up nearly 70% of the entire universe. It's literally the dominant ingredient in the cosmos, and yet we have almost no idea what it actually is. Some scientists think it might be a property of space itself, an energy built into the very fabric of the vacuum. Others suggest it could be something dynamic, like a new kind of field or force we haven't discovered yet. There are even theories that our understanding of Einstein's general relativity might be incomplete, and that gravity works differently on cosmic scales. The evidence, though, is undeniable. Every observation, galaxy surveys, cosmic microwave background radiation, large-scale structure, points to the same conclusion. Something is accelerating the universe. If dark energy didn't exist, the universe might eventually slow down, collapse, or reach a stable state. But with dark energy in the driver's seat, the future looks very different. Billions of years from now, galaxies will drift so far apart that their light won't even reach us. The night sky could turn dark and empty, each galaxy isolated in its own bubble of space. Dark energy is the biggest mystery in modern cosmology. It's not just a question of what it is, it's a question of where the universe is heading. And right now, all signs point to a cosmos that's only getting bigger, faster, and stranger. Life on Mars? Mars has always been the #1 suspect when it comes to finding alien life close to home. It's cold, dry, and covered in rust-colored dust today. But the planet wasn't always like this. Billions of years ago, Mars had rivers, lakes, and even oceans. It had a thick atmosphere, flowing water, and conditions that look a lot like early Earth. Which raises the obvious question, did life ever start there? The search has been going on for decades. The Viking landers in the 1970s even carried experiments to detect microbial life in the Martian soil. The results were weird. Some tests hinted at possible chemical activity that looked biological, but nothing conclusive. Since then, rovers like Curiosity and Perseverance have drilled into rocks, sniffed the air, and looked for signs of organics. One of the strangest discoveries came in the form of methane. On Earth, most methane comes from living things, and on Mars, scientists have detected mysterious methane spikes in the atmosphere. Sometimes the gas is there, sometimes it disappears. No one knows what's causing it. Could it be microbes underground still clinging to life? Or is it just strange geological chemistry? Then there are the Martian meteorites that have landed on Earth. One of them, called ALH 84001, made headlines in the 1990s because under a microscope, it seemed to show tiny fossil-like structures. NASA announced it might be evidence of ancient Martian bacteria, but later studies suggested those shapes could also form naturally without life. Today, Perseverance is caching rock samples that future missions will hopefully bring back to Earth. Those samples might finally give us a clear answer. The question of life on Mars is maddening because it feels so close. Every rover picture, every strange chemical spike, every new discovery hints at the possibility, but never confirms it. Maybe Mars was once alive, maybe it still is, or maybe it never was at all. Until we hold those samples in our labs, Mars remains the ultimate almost in the search for alien life. Venus's PHOSPHINE puzzle. Venus is one of the last places you'd expect to find life. The planet is a nightmare. Temperatures hot enough to melt lead, crushing air pressure, and clouds filled with sulfuric acid. It's often called Earth's twin because of its size, but in reality, it's more like Earth's evil twin. And yet, in 2020, astronomers found something that sent shockwaves through the science community. Phosphine gas in Venus's atmosphere. On Earth, phosphine is almost always associated with life, produced by bacteria in oxygen-free environments, or artificially in industrial processes. Finding it floating in Venus's clouds raised one shocking possibility. Could there be microbial life surviving high above the planet's deadly surface? The idea isn't completely crazy. The surface of Venus is hellish, but 50 kilometers up in the atmosphere, the conditions are much milder. Temperatures closer to Earth's and pressure that a human could theoretically survive in with protection. If life ever got started on Venus long ago, maybe it retreated to the skies and adapted to living in the clouds. But of course, nothing is that simple. The phosphine detection itself has been controversial. Some scientists argue it was a false signal, a mistake in the data. Others say it could be produced by strange, high-temperature chemistry we don't fully understand yet. A few papers even reanalyzed the observations and found no phosphine at all. So what's the truth? Right now, we don't know. The evidence is debated, and new missions will be needed to settle it. Luckily, both NASA and ESA have upcoming spacecraft headed to Venus in the 2030s, and they might be able to confirm whether the phosphine signal is real, and if it is, what's causing it. The Venus phosphine puzzle is frustrating because it sits right on the edge of possibility. It might be the first sign of alien microbes in our own solar system, or it might be nothing more than chemistry playing tricks on us. Either way, it reminds us that even the most hostile worlds might hold secrets worth chasing. Enceladus and Europa, oceans beneath the ice. When we think about where life might exist in our solar system, our minds usually jump to Mars. But the real game changers might actually be two icy moons: Enceladus, orbiting Saturn, and Europa, orbiting Jupiter. Both look like frozen worlds at first glance, covered in thick shells of ice, with no sunlight reaching the surface. But beneath that ice, scientists believe there are vast global oceans of liquid water. And where there's water, there's the potential for life. Enceladus shocked the world in 2005 when the Cassini spacecraft flew past and saw geysers of water vapor blasting into space from cracks at its south pole. These plumes weren't just water. They contained organic molecules, salts, and even hints of hydrothermal activity at the ocean floor. On Earth, hydrothermal vents at the bottom of our oceans are home to entire ecosystems, thriving without sunlight. So if similar vents exist on Enceladus, who's to say something couldn't be swimming around down there? Europa has been teasing scientists for decades. Its cracked, icy surface looks like it's floating on an ocean beneath. The Hubble Space Telescope has even spotted what may be plumes of water shooting into space, similar to Enceladus. With a liquid ocean, an energy source, and the right chemistry, Europa checks all the boxes for habitability. But here's the catch. We've never directly looked. No spacecraft has drilled through the ice or scooped up samples from those plumes. We've only flown by, stared from a distance, and dreamed of what might be hiding underneath. Could it be simple microbes? Could it be something more complex? Or could it be lifeless oceans, sterile despite all the ingredients being there? The good news is, new missions are coming. NASA's Europa Clipper launches soon, and ESA's JUICE mission is already on its way. Within the next couple of decades, we may finally get close enough to know the truth. Enceladus and Europa are the ultimate cosmic tease, worlds that seem like they should host life, but refuse to give up their secrets. Until we break through the ice, they'll remain two of the most tantalizing mysteries in the solar system. The Fermi Paradox. The universe is unimaginably big. Hundreds of billions of galaxies, each with billions of stars. many of those stars with planets. Statistically, it seems almost impossible that Earth is the only place with life, and yet, where is everybody? That's the Fermi Paradox. The name comes from physicist Enrico Fermi, who casually asked over lunch in 1950, if aliens exist, then where are they? It sounds simple, but it's one of the most haunting questions in science. By now, with all our telescopes and technology, we should have seen something, a signal, a probe, a footprint of advanced civilizations, but space remains stubbornly silent. So what's going on? Theories range from hopeful to terrifying. Maybe life is actually much rarer than we think. Yes, planets are common, but maybe the conditions needed for intelligent life are so specific that Earth really is one in a trillion. Or maybe civilizations do exist, but they don't last long, wiped out by war, environmental collapse, or disasters before they ever reach the stars. That's called the Great Filter. And if it's ahead of us, that's bad news for humanity. Then there are the "they're out there, but we just don't see them" theories. Maybe aliens are so advanced their technology looks like natural phenomena to us. Maybe they're deliberately hiding, following a cosmic version of the Prime Directive. Or maybe they're talking in ways we don't know how to listen to, using physics or dimensions beyond our comprehension. And of course, there's the unsettling idea. Maybe we really are alone. Maybe intelligence is so rare that in the vast darkness, humanity is the only voice. The Fermi Paradox is maddening because every answer is either humbling, terrifying, or both. Either we're the only life in a sea of stars, or we're surrounded, and we're just too small to notice. In a universe this big, silence might be the loudest mystery of all. The Great Attractor. When astronomers map out the universe, they notice something odd. Galaxies aren't just floating randomly. They're moving, drifting through space under the pull of gravity. That makes sense. But in the 1970s, scientists realized our entire galaxy, the Milky Way, is being pulled towards something huge in the sky. They called it the Great Attractor. The problem? We can't actually see it. It sits in a region of the sky blocked by the Milky Way's disk, hidden behind clouds of gas, dust, and stars. But its gravitational effect is undeniable. Our galaxy, along with hundreds of thousands of others, is being tugged toward this invisible spot at hundreds of kilometers per second. It's like we're all sliding downhill towards something massive, but we don't know what's at the bottom. So what could it be? Some say it's just a supercluster of galaxies, a huge concentration of matter creating a gravitational well. Others suggest it could be something even larger, a dark flow of the universe itself, pulled by matter or forces beyond the observable horizon. If that's true, then part of what's dragging us isn't even in the universe we can see, it's in the unknown beyond. Later studies showed the Great Attractor is part of an even bigger structure called the Laniakea Supercluster, a cosmic continent of galaxies stretching 500 million light-years across. Our Milky Way is just one small piece of this gigantic web. But even with that explanation, the mystery isn't fully solved. We still don't know what's really at the core, or why the pull is so strong. The Great Attractor is unsettling because it reminds us how tiny we are. Our entire galaxy, billions of stars, planets, everything we've ever known, is being dragged like a grain of sand in a current we can't control. And the truth is, we may never know what waits at the center of that pull. In the grandest scale, the universe doesn't just expand, it also moves. And somewhere out there, an invisible hand is tugging us toward the unknown. The Big Bang and what came before. About 13.8 billion years ago, the universe as we know it exploded into existence in what we call the Big Bang. Space itself expanded from a point smaller than an atom, creating all the matter and energy we see today. The evidence is everywhere. The leftover glow of the Big Bang in the cosmic microwave background, the way galaxies are rushing apart, the abundance of light elements like hydrogen and helium. But here's the problem. The Big Bang explains what happened after the universe began. It doesn't explain what caused it, or what, if anything, came before. That's where the mystery deepens. One possibility is that the universe emerged from quantum fluctuations in a vacuum, that even nothingness isn't really empty, but bubbling with energy. Another idea is cosmic inflation, where the universe expanded faster than the speed of light in its earliest fraction of a second. Inflation explains a lot, but it raises new questions. What triggered it? and why did it stop? And then there are the wilder theories. Maybe our Big Bang was just one of many, part of a multiverse where new universes are constantly being born. Maybe our universe is the rebound of a previous one that collapsed in a big crunch. Or maybe time itself only started with the Big Bang, meaning the question, what came before, doesn't even make sense, because there was no before. The most unsettling part is that we might never be able to test these ideas. Our telescopes can only see so far back, about 380,000 years after the Big Bang, when the first light was released. Before that, the universe was opaque, and the evidence of its birth may be forever hidden. The Big Bang is both an answer and a question. It tells us how the universe grew, but not why it began. Did something light the cosmic fuse, or did the fuse light itself? Until we solve that, the very origin of everything remains one of the greatest mysteries in existence.